Hello everybody, myself Nidhi Joshi, and in my today's session I am going to discuss about what is a quick sort. Quick sort is a sorting algorithm that uses divide and conquer strategy. In this method, the division is carried out dynamically, and the quick sort involves the three steps. First is the divide, conquer and the combine. So first we'll see the divide. In the divide, we are splitting the array into two subarrays such that each element in the left subarray is less than or equals to the middle element, and each element in the right subarray is greater than the middle element. The splitting of the array into two subarrays is based on the pivot element. The elements that are less than the pivot are in the left subarray, and all the elements that are greater than or more than the pivot should be in the right subarray. Here in the second step, that is the conquer. So here we are recursively sort the two subarray, and the third step is the combine. We are combining all the sorted element in a group in order to form a list of the sorted element. Here one more important point is there related to the quick sort. In the quick sort, the division is based on the actual value of element. So here comes the two important concept. First is like how we are selecting the pivot element, and second one is how quick sort algorithm, how the quick sort procedure will work. To clear both this concept, both this point, let us consider a simple array. Let us consider an example. So the first element of here we are having an array, unsorted array. The first element of the array is taken as the pivot element. After considering the pivot element or selecting the pivot element, we are splitting the array into two parts. The left sublist will contain the element less than the pivot. The pivot is 5. And the right sublist contain the element greater than the pivot. This is the I, this is J, high and low. So after selecting the pivot, we are incrementing the pointer from I. The pointer comes at this place. Here we'll see array of I should be less than equals to the pivot element. So we are checking 3 is less than equals to 5. So we'll continue incrementing until the element pointed by I is greater than the pivot element. So after this, the pointer is incremented. It's now pointing at 8. Pointer is incrementing and is pointing at this place. So here we'll see the array of I is less than equals to the pivot element. This condition is not satisfying here. So here we are checking with the array of J. Here we are checking the array of J should be greater than the pivot element, because the element in the right sublist or in the right subarray should be greater than the pivot element. So here we are checking the 4 is greater than 5. This condition is also false. So that time what we are doing, we cannot increment the I, we cannot decrement the J. So what we are doing, we are swapping array of I and array of J. After performing the swapping, we got the list like this. Okay. So after this, we are the next step of a quick sort algorithm, we are checking the array of I should be less than the pivot element. Condition is true. Now we are incrementing the I value. That thing we'll see in the next slide. Yes. So after incrementing the I, now the I pointer is pointing at the element 9. So after this we are checking, we cannot further increment the I values. So the next step is like we are checking the array of j. Array of j should be greater than the pivot element. We'll check. Yes, the condition is true. That time we'll decrement the array of j. After decrement also, now the array of j is pointing at this place. So j cannot be decrement. If this condition here also we are occurring this condition, so we are swapping both the values. After performing the swapping, we got the list like this. So after performing the swapping, we are checking the array of I value. We are incrementing I. If we cannot further increment the I pointer, we'll check the array of j. If we cannot decrement, that time we are performing the swapping. So after performing this further quick sort, we are getting the list like this. So further we cannot increment or in simple word, when j crosses I, that time we are swapping the pivot element with the array of j. So here this list we got after performing the swapping. After performing the swapping, here is one important analysis is there. In the quick sort, the pivot element is placed at its proper place, and the list is like this. The left sublist contain the element that are less than the pivot element, and the right sublist contain the element that are greater than the pivot element. So here in the quick sort algorithm, that is performing the two important function. First is the partition function, that is performing the arrangement of element in the ascending order, or in a simple word, it is used to arrange the elements such that all the elements that are less than the pivot elements are in the left sublist, or all the elements that are greater than the pivot element are at the right of the pivot element. Or in a simple word, or in other word, the pivot element is occupying its proper place and the partition list is obtained in a ordered manner. Ordered manner, it means that the elements that are less than pivot are in the left sublist and the elements that are greater than pivot are in the right sublist. So this thing we are getting it after the first iteration. Now in the second iteration, we are dividing the left sublist, applying the quicksort algorithm on the left sublist, quicksort algorithm on the right sublist. The procedure is like, first we are selecting the first element as the pivot element. We are incrementing the I values, checking whether we can increment the I pointer or not. If not, that time we'll check the j pointer. We can decrement the j pointer. If we can decrement, we'll see both this condition. If j crosses I, that time we'll swap the value of the array of j with the pivot element. The purpose is that we got both the sublist, that is the right sublist and the left sublist, in a sorted manner, and each and every time the pivot element is getting the proper place in a array list or in an organized, in an ordered manner. The partition list is obtained in a ordered manner. So, after swapping the element, after performing the iteration, we got the unsorted list in a sorted manner. Or this is the output or the result after performing the quicksort approach. Now we'll see the analysis of the quicksort. It uses the divide and the conquer approach. If we are talking about the time complexity of the quicksort, the time complexity for best or the average case is the order of log n log n. Here, if the array is always partitioned at the mid, then it brings the best case or the average case of an algorithm, which is given as the order of n log n. Now, if we are talking about the worst case of the quicksort, the worst case for the quicksort occur when pivot is a minimum or the maximum of all the elements in the list, which is given as the order of n square. And for in order to find the best case and an average case, we can use the master theorem or the substitution method. Either we can use the forward substitution or backward substitution. So, in my today's session, I had discussed about what is a quicksort, how the quicksort algorithm works. We had understand this concept along with one example, and after that we saw the analysis of the quicksort. That's all in the today's session. In case if you are having any queries related to quicksort, you can ask me. Thank you.